Well, good afternoon and welcome back to the Johnson Space Center, and thanks for joining us on short notice. We're holding this ISS status briefing today to bring you up to date on developments on the station and upcoming activities. We only have 45 minutes today for the briefing due to other commitments by our briefers, so we'll get underway right now. And with us today are Mike Suffredini, the International Space Station Program Manager, and Norm Knight, the Chief of the Flight Director Office here at the Johnson Space Center. And we'll start off with Mike.
Good afternoon. We're here today to talk a little bit about an EVA that we're going to conduct tomorrow morning on the U.S. segment of the International Space Station. As many of you probably have seen in some videos, a little before lunchtime yesterday, the crew called down. They were seeing flakes of snow coming off the space station itself. You can see this in this video here. Consequently, about the same time, the ground team was looking at a data drop in quantities on the ammonia cooling system on what we call the 2B power system. It is one of the two power systems on the port outermost array set. And what the data was showing us was that the quantity was dropping. This is the system that has been leaking for some time. Actually had a very small leak for many years. Last summer, however, it took a bit of a turn for the worse, and as you might recall, we did an EVA. We weren't exactly sure what the leak source was, but if you looked at all the possible scenarios, an MMOD hit to the cooling radiator was a most likely cause. And so we sent the crew out in the November time frame to isolate that radiator and hook up to a radiator that we used in the early system on board ISS. That was a completely successful EVA, and over the last several months, 6 to 7 months since that time, the system has been operating well. The radiator we isolated has not been leaking, so the source of the leak is not there, and we continue to see a smaller leak, not quite as dramatic as before we did the EVA, about on the order of 5 pounds a year. But early yesterday morning, the data shows that changed significantly to about a 5-pound mass ammonia leak per day. And with that, it was predicted that the system would shut itself down by either late tonight or early tomorrow. So the first thing we did was we worked together as a team to move all those power loads off the 2B array, mostly to what we call the 2A array, and then shut down the system in order to preserve the ammonia as much as we can. And with that, we got very fortunate that the crew members we have on orbit have been out to this IEA before. In fact, we had done quite a bit of work on the change out of the pump in question as a preparatory act for the previous EVA we did in November. And so the team was really very ready to try to go outside and take a look at this. Our primary objective really is to try to get a look at the leak. When it's at this pressure and we're single phase in the lines, we produce this snow when we leak. But these cracks or holes or whatever is leaking is very, very small. And so once the leak goes down to a point where you don't see the snow anymore, it'd be very hard to find. Since the crew is prepared and our ops team is ready to go, we're going to get them outside and see if we can't lay eyes on the actual leak source. While we're there, the next most likely cause really is the pump itself and the QDs associated with the pump. So we're going to go ahead and change out that pump and see if we can't recover the system. Keep in mind that depending on how much ammonia is left, once we change the pump out, we may not be able to start the system right up. We may have to wait to a subsequent EVA to fill the system up. That'll depend on how much ammonia we lost between now and the EVA and whether or not the change out of the pump actually arrests the leak or not. So the team's ready to go. Norm is going to talk to you a little bit about that now. It does not affect the crew's departure. During this EVA, we'll use Tom, who's in the right seat of the Soyuz, and Chris Cassidy, who actually is going to remain on board when Tom and Chris Hatfield and Roman depart Monday afternoon. So we've got Tom's in good shape to go do the EVA and then get on board the Soyuz for a nominal return. And so we'll do the EVA tomorrow and bring the crew home on schedule on Monday. And so with that, I'll go ahead and let Norm tell you a few more of the details.
All right, thank you, Mike. The team's in good spirits. What I'm going to cover today is to give you some insight into what the team has been doing over the past 24 hours since this leak was detected, and talk about the activities that the crew has performed today in prep for the EVA, and then I'll talk a lot in detail about what tomorrow's activities are as well. Today, for the last 24 hours, the ops team and many other teams have been in a full court press to understand what the failure is. We did this several ways. First, we acquired a great deal of imagery. We have cameras on the external truss and external modules of station that provided some very good insight into to the leak, that some of the video that Mike showed you earlier. We also had the crew perform some handheld camcorder video as well to provide that insight as well. So we got a lot of imagery. We've narrowed it down to the P6 solar array and in the IEA type area, and you saw that video earlier, and I'll show you some graphics here in just a few minutes. So the imagery helped tremendously in being able to pinpoint this, and that also led into the EVA planning. So the EVA planning, again, we hit the ground running 24 hours ago, knowing that we needed to get out to the P6. As Mike mentioned, the crew is very familiar with this area, so we're very fortunate that they've had experience in this area. So the planning went on all night. We put together a timeline and have a very good idea of what is required to go out and effect a change out and provide some visual inspections once they're out there, and I'll go through that in detail in a little bit. But I'd be remiss not to mention that there is a lot of analysis that goes into this. There's a lot of work behind the scenes that's taking place throughout the night to make this possible. So there's a lot of teams doing a lot of good work to get us where we think we'll be ready to go out the door tomorrow morning. So today's activities, the crew woke up at around 1 a.m. and we're very excited to hear that they would be going out the door possibly Saturday. And so that made for a very happy day on their part. They have been doing EVA prep activities today, suit resizing, looking at the procedures. The ground team has done an excellent job of getting the procedures on board so that the crew can review those. They've had conferences with the ground. In fact, on the way over here, I got a report that the crew was talking with the ops team and going over those procedures, and they feel real good about them. And we were working out some last-minute details. So things are really progressing in the right direction. The crew will be going to bed at around 16:30 Central Time, and we'll get up tomorrow morning bright and early for their EVA day. So tomorrow they will wake up around 1 a.m. Central Daylight Time. EVA prep will begin at around 2:15 in the morning, and that will conclude with hatch opening around 7:15 a.m. Central Time. So that'll be very exciting. Once outside, the crew will spend about 45 minutes getting their tools configured, getting all their tethers configured, and start heading out to the work site. And if we can go to the first visual coming up here, there we go. That's the work site that they will be at. It's labeled the 2B PFCS, and what's denoted there in yellow is a pump package. Their work site is about 150 feet away from the airlock, so they will transit out along the truss on the port side to the solar array that you see there in the picture, and the work site that's denoted with the red arrow. Once at the work site, what they will be doing is performing a visual inspection. If we can go to the second graphic. They'll be performing a visual inspection around the area in yellow there depicted, and that will provide better insight and complement the imagery that we gained yesterday to try to pinpoint where this leak is. So we're going to gather as much information as we can from the visual standpoint, and the crew will then take that PFCU out. There are two lock bolts that run up and down in the picture there, and there's two quick disconnects that are actuated with two bolts on the left and right side of that yellow box. So they will take that box out and they will temp stow it. The crew will then perform a visual inspection down in the bay where that box came out. They will also look up under the box to make sure that there is nothing anomalous or anything that could provide some insight as to where this leak might be originating from. If we go to the graphic on number 3, that's the box in question. And if you see there on what's depicted as H1 and H2, those are the 2 bolts that will release the quick disconnects. Those are what interfaces the ammonia system to the pumps that are inside that box and provides the flow through the integrated electronic assembly and radiators in the system. The other 2 bolts, the H3 and H4, are the structural bolts which hold it down into the bay. And we can go to the next graphic, and it provides a nice view of the underside of this box. It's aluminum structure, and the 2 conical cones that you see there are the 2 structural bolts, and you can see the QDs towards the front of the picture on either side. So the crew will temp stow that box. They'll get some imagery. The ground team will look at that as well. And then they will translate out several feet to pick up the spare pump package. They will remove that from the spare platform. They will put it in and replace the hopefully anomalous pump package. Bolt that down, integrate the QDs in, and then take and stow the anomalous pump package back in that slot. And that really concludes most of the activities that are going to be objectives that we want out of the EVA. At this point, they're going to do a visual inspection. We know there's ammonia in the area, as evidenced by the video that Mike showed earlier. So they'll do a visual inspection of each other to make sure that there's no ammonia ice on their suits. And once they have concluded that they are clean, that starts a bake-out timer. And we do that to make sure that we have adequate time for any hidden ammonia that might be on the suits to evaporate. And on rough order of magnitude, 30 to 45 minutes is required for that bake-out time. So they will, that clock starts, and they will begin their transit back to the airlock down the P6 truss. And once they get in the airlock, they will hook up on umbilicals. They will repress the airlock to around 5 psi. And perform a test. It's a Draeger tube, and it's just a simple way of detecting how much ammonia might be in the atmosphere at that 5 psi level. And based on that, we'll make a determination of if there's contamination or not. If consumables permit, they may do a second test. We don't anticipate that to be required. And if consumables don't permit, then they'll go ahead and press the airlock up and come back into station. So we're looking forward to a very good day tomorrow. A lot of hard work, full court press, and we're real excited. That's all I have, Rob.
Okay, thanks, Norm. We'll take questions now, starting here at JSC with Robert Perlman.
Hi, Robert Perlman with CollectSpace.com. You mentioned that you were fortunate to have crew members who've worked in this area before. Did that drive the desire to do this EVA now before the undocking and not waiting for the next crew to come up, or what were the pressing needs to do this so quickly?
That's a good question. I would say it a little differently. The fact that these 2 crew members have been out before and done an EVA together in this area is one of the many factors that allowed us to do the EVA before they departed. The system, the ISS, is fine with 7 of 8 channels, and so we really don't need to rush for that reason. As I tried to say earlier today, one of the unique opportunities here is that the leak is big enough and the conditions are right, at least at this phase of the leak down, that if we can get in there and actually see the origin of the leak because it's still emitting snow, ammonia snow, then we have a chance of figuring out the source of the leak, obviously, and then what we're going to do about it. Oftentimes, these leaks are so small that if it's not snowing, you won't notice it with just eyeballs staring at the metal. You're talking about very, very small holes or cracks, and so they'll be difficult to identify if we lose these conditions. So that's really what's driving us outside. It's really not the need to get the power system back that quick. It's really we have a unique opportunity until the pressures go down much more to actually visually identify if in fact it's in an area where we can get to, but to visually identify the source of the leak.
And a follow-up for Norm. Given how quickly this plan came together, how does this compare to other unplanned EVAs that have been done over the station's life? Are you getting better at pulling together a quick plan for EVA, or was this just a unique situation given